Hello friends, Dr. Jim Daly here from Astronomy for Change, and welcome to the next installment of the 10 Brightest Stars in the Night Sky. Tonight we're going to present the star Sirius, the dog star. It's only appropriate now as the winter is upon us. The winter solstice is just a bit over 10 days away on the 21st, exactly, 9 days away on the 21st. And don't forget too, a previous video we talked about a beautiful conjunction of the large planets, the major planets, Jupiter and Saturn, that will be visible on that date. Not to be seen again like this, such a conjunction, for 60 years hence to the year 2080. So make sure you check it out. We open up this evening's view looking south-southeast. We see the constellation Orion. It's about just not quite 7:30 in the evening today, December 12th. All the beautiful stars. The winter sky is one of the times of the year when we have the highest density of the brightest stars. Many of these stars are much larger and more powerful than our sun, for example, in the constellation of Orion. And we're going to get to talk about that in a later video. Betelgeuse is a red supergiant star. Rigel is a blue-white giant, and Aldebaran in the constellation of Taurus is also a red giant star. We're going to be talking about those in a later video, but tonight we want to take a look at the star Sirius. Okay, I'm going to let the sky drift ahead slowly as we wait until Sirius rises. It becomes well placed around about 9:30, high in the south. Well, not quite so high. This is about 10:30 at night tonight, and we see Sirius just below Orion, to the southeast of Orion. We follow the belt stars of Orion straight through, points to the star Sirius. Okay. Turn on the constellations. Impression the ancients had of these mythological creatures and characters in the sky are easily depicted here in Stellarium. Canis Major with Orion, the great hunter, hunter of the winter sky. Now, if we turn off a Milky Way, we turn off the atmosphere, we can see the sky takes on a whole new character. We're witness to what we call the winter Milky Way. During the summer months, the Milky Way is quite striking. When we look towards the south, most notably towards the south, we're going to see the galactic center with the stars of summer that include Sagittarius, Scorpio, with Antares. We talked about those stars in several videos previously. But the winter Milky Way is more subtle, and you can see it right here, just to the east of the constellation of Canis Major, which has Sirius as its principal star. So, all right, so let's zoom in on Sirius here. I'm going to zoom in. Sirius is what we call an A-class star. Stars are categorized in what we call spectral classes. Our sun is a smaller, somewhat cooler star than Sirius, has a much longer lifespan, and it's a G-type star. Going up two categories on the spectral scale, we're going to go from G, which is our sun, to F, and then to an A star. Sirius is an A-class star, which means that it's going to it's much brighter. And Sirius is bright, I should mention while I'm here, Sirius is bright for two reasons. First of all and foremost, it's very close to us. Less than 9 light years away. It's 8.6 light years. So the light we see tonight left that star 8.6 years ago. And secondly, since it's an A-class star, it's going to be bright anyway, okay, regardless. Its intrinsic or its fundamental luminosity, its fundamental brightness, its absolute brightness is much higher than that of the sun. So clearly it's going to be very bright in our sky. And consequently, it's going to live a much shorter life. Maybe no more than 1.5 to 2 billion years completely in total, its entire life cycle is no more than 2 billion years, whereas our sun, it has a projected lifespan of being 10 to 12 billion years. Right now, our sun is 4.5 billion years old, and before it starts to evolve and start to run out of its complement of hydrogen, which is at its core, every star converts or transmutes 4 hydrogen nuclei, protons, into helium every second of every day. That's through nuclear fusion. That's how stars produce energy. Our sun is doing it. Sirius is doing it. Most of the stars you see in the sky are doing that same thing. A lot of the stars, let me back out of here for a moment. Many of the bright stars we see in our winter sky, stars such as Rigel and Betelgeuse and Aldebaran and Taurus, have evolved away from that evolutionary path we call the main sequence to now start consuming the helium that was produced all these billions of years, in the case of some of these stars, millions of years, through nuclear fusion, converts 4 hydrogen nuclei and produces helium. Now, these stars, they're evolved stars. They're no longer on that path we call the main sequence, and they're producing helium. And they're using helium as a nuclear fuel that's producing carbon and some oxygen. Okay, but getting back to Sirius. Sirius is on the main sequence star. It's an A-class star. Its lifespan is going to be about 2 billion years. So there's no way any planet in orbit around Sirius would be able to, projected into the future, would be able to have life evolve and thrive as it did here. The star simply doesn't live long enough. Okay? Here's a telescopic view that I produced of Sirius with a 20-centimeter Newtonian astrograph a number of years ago. You can see the star here. These spikes simply are artifacts of the telescope's optical system. It's not part of the star. And you can see the companion stars here are complement the stars we see here in Sirius, around Sirius. So if we were to look at these stars, for example, right here, we would see them right here. Okay, so this is an actual telescopic view of Sirius through what they call an astrograph, where a telescope is converted to a giant camera using the primary optical system of the telescope as the imaging component that produces, the image. Okay. So Sirius is the brightest star in our sky for 2 reasons. It's relatively close to us, at only less than 9 light years, and it's an A-class star, which is considered bright. We talked about in a previous video in this series, the star Vega is also an A-class star. Like Sirius, Vega has a similar lifespan of approximately 2 billion years before it winds up expanding to become a red giant star and starts to use the helium that has built up as the nuclear fuel in the next series, and then in the next burning cycle, what we call burning cycles. Okay? All right. I'd like to take us on a little tour of the night sky here in this vicinity around Sirius. Canis Major and this whole region of the sky is brilliant, and many astronomers refer to this as the sky's winter jewel box, the jewel box of stars here in the winter sky. As you can see, it's replete with many bright stars: Sirius, Wesen, in Canis Major, Rigel, the belt stars of Orion, Betelgeuse and Bellatrix, these 2 shoulders of the giant hunter and his knees down here. Okay, mythology tells us that the great dog, Canis Major, the great dog, is the hunting companion to the great hunter Orion. And I might mention also that his lesser sibling is Canis Minor, right here. Let me turn on the constellations again. right here, Canis Minor, with a lesser dog, right here. Canis Major, Canis Minor. Okay, we'll get to talk about Procyon and Canis Minor in a subsequent video. But for tonight, for now, we're going to take a look more at the constellation of Canis Major. Okay, zooming in right here. Now, as we zoom in on this field, this region of the sky, all kinds of beautiful stars and aspects of this region come into play. Here we have Messier 41. Right here, I'm going to center it on the screen. You can see it. This is Messier 41, the 41st entry in Charles Messier's catalog of non-cometary objects, objects that you, an exclusion list basically. If you don't want to look, if you want to look at comets, you don't look here. So this is the 41st entry in Charles Messier's catalog of non-cometary objects. Charles Messier was a comet aficionado. He enjoyed and he observed comets. That was his mainstay in astronomy. That was one of his principal activities as an astronomer. He was a French astronomer, lived in the 17th to 18th centuries, was to look at and catalog comets. So this is his 41st entry, Messier 41. Now, let's go back here. I'm going to share with you. Telescopic image of Messier 41 that I took, again with that same instrument, 20 centimeter or an 8-inch, it's an 8-inch objective, the size of the mirror. The principal imaging optical component is 8 inches or 20 centimeters in diameter. Okay, and this is a 5-minute image, a 5-minute exposure, a number of years ago, more or less at the same time that I imaged Sirius. This is Messier 41. Messier 41 is what we call a galactic or an open star cluster, consisting mainly of young blue-white stars, many of them similar to the star Sirius, which we're studying tonight, which is tonight's object of interest. Okay, go back here, and you can see a striking similarity in the two images. So that's Messier 41. All right, zooming back out. I'd like to share this with you also while we're thinking of it here. Canis Major. On an excursion to the Florida Everglades, I imaged this with a 100 millimeter f2.8 lens in January of 1986 on the occasion of the apparition of Halley's Comet. Was visible. This comet with a 76-year period was previously observed in 1910, 76 years hence, 1986. I went to the Everglades to observe Halley's Comet. And we see here, I took this image. This is the constellation of Canis Major. Here's Sirius. And if we go back to Stellarium, we zoom out here, you can see it clearly right here. Here's the star Wesen. Here's Sirius, as you can see here. Okay. Another object of particular note is a cluster that surrounds Tau Canis Majoris, right down there. Okay, let's take a look. Here we go. Let's zoom in on that. Okay, here we go. Here's the cluster. Zooming in with Stellarium. Okay, this is a young, what they call a galactic cluster that surrounds the star. Just like right here. Okay, that's the cluster. Also imaged by me with that same instrument about the same time as I imaged the rest of them a number of years ago. Okay, this is Tau Canis Majoris right here, surrounded by this beautiful galactic cluster, NGC 2362, New General Catalog 2362. All of these objects are placed here in Canis Major as part of what we call the winter jewel box. Okay. go back to our image of Canis Major here. Okay, so if we zoom out, okay, zoom out a little more. Wesen right here. It's 2362, Messier 41, Sirius, all together here. Okay. While we're here, let me also share this with you. This is a star chart with companion image that we just looked at, my image here. And this is a public catalog star chart, a public star chart available through. The details for this chart are going to be, I'll make them available in the comments section in this video. But this is the area of interest right here. This is Canis Major. And in this particular chart, in these particular diagrams, the brightness of the star is indicated by its size on the chart. So Sirius is a very bright star. It's the brightest star in our sky, right? So here we have NGC 2362, which is right here. And we have Messier 41 right here, also visible right here. So there's a one-to-one correspondence between this chart, excuse me, this image, my photo, taken from the Everglades, and this star chart right here. Now, I want a special treat that I always, Universe Sandbox. Here we open with the sun front and center with our planets, with the planets in our solar system in orbit around the sun. And what we usually do with what we've been doing, is we replace the sun with the star of interest. In this case, would be with Sirius. So we select the sun, and watch what happens to the planets as soon as we replace the sun with Sirius. Notice how peaceful everything is. The way it is now. We choose the star, Sirius, replace. Immediately, watch what happens. Now, Sirius is twice the mass of the sun. And what do you suggest, what do you think was going to happen if I replace something that's one solar mass, which is the sun, with something twice the mass? What do you think is going to happen? Watch what happens with the planets. Let's zoom in a little bit. Look what happens to Mercury. Mercury already has a highly eccentric orbit. Watch what happens now. Look at Venus. It's being drawn towards replacing, well, almost a collision there. Replacing the sun with Sirius. Look at, now, I'm going to select Mercury. Let me pause this simulation. Mercury's close to the sun. Mercury's already hot. Look what happens to it now. Not only does it speed up, the planet's going to go perhaps twice as fast in their orbits, but look at the temperature. The surface temperature is 1086 degrees centigrade, or almost 2000 degrees Fahrenheit. That's almost 3 times the melting point of lead. Okay. Continue the simulation. Watch what happens now. Watch what happens. See, this updates in real time. As the planet moves away from the source of the energy, which is Sirius, the surface temperature is going to cool, which is what you would expect. So it's updating it in real time. Okay. Let's choose the Earth. Here's the Earth. (470 degrees centigrade Celsius). let's see, that's almost 900 degrees Fahrenheit. Talk about global warming. Look at how far away at this point the Earth is from the source, which is Sirius. So you can see what would happen to all the planets, to the entire solar system, if we were to replace the Sun with Sirius. It's an A-class star. It's not even the brightest or most luminous of them all. In fact, above this is the B-class, and the O-class stars are the most luminous. Okay? Let's see what the temperature is at Jupiter. -31 degrees below 0 C. 24 degrees, minus 24 degrees Fahrenheit. Okay? I mean, we see temperatures like that in around the Arctic Circle. Jupiter normally is much, much colder. It's about 120 below 0 centigrade. 120 centigrade, minus 120 centigrade. Okay? So, now, watch what happens now with one thing I haven't mentioned yet. Sirius is actually a binary system. In orbit around Sirius is a white dwarf companion, a white dwarf star of approximately one times the mass of the Sun, or 1 solar mass. It has a period of approximately 50 years with a semi-major axis, or a radius of about 19 astronomical units, which is the distance to the planet Sirius, the planet Uranus. So I have that ready to go here. Let's take a look at what that looks like. Right here. Launch that simulation. There it is. Okay, let's start the simulation. There's Sirius B and Sirius A. So Sirius, it's a telescopic binary. You need a very powerful telescope to see the binary. And it's a test for moderately sized or small professional telescopes, a moderate to large amateur telescope. This is a test of the quality of the optics. If you can resolve this star with your telescope, then you have a good set of optics in the telescope. And there it is. Let's take a look at its properties. Take a look at the motion. See, you can watch the distance. It's updating in real time. Its orbital period is approximately 50 years with a semi-major axis. The semi-major axis is the distance from the very center of the ellipse. This is an ellipse. All orbits are elliptical. The great mathematician and astronomer Johannes Kepler gave us 3 laws of orbital motion. The first of those laws is that all orbits are elliptical. Okay, so the very center to the furthest point here is called the semi-major axis. So if we were to bisect the ellipse this way, that's the major axis, this is the minor axis. The semi-major axis is the distance from the center to the long side here. And that's 19.6 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun, or about 150 million kilometers. Okay? Now, what would happen if we were to put this system, replace the Sun with this system? Now, keep in mind that Sirius B is a white dwarf. It's one times the mass of the Sun. It's 1 solar mass. So the combined mass of this system, Sirius is 2, this is 1. The combined mass of this system is 3 solar masses. Okay? Sirius B is the burned out core of stars that were once like our Sun, and perhaps Sirius as well. Okay? And it's possible that because it's very small and very dense, it's got an enormous gravity. White dwarf stars have enormous gravity, and Sirius, being twice the mass of the Sun, has also a very strong gravity. So it's most likely that Sirius B was captured by the strong gravitational attraction between both of these 2 stars, and it went into and adopted this orbit of 50 year period. So let me open simulation here. We will replace the sun with this system and watch what happens. Watch what it does to the solar system. Right away, start the simulation. Here's Sirius B, right? This is a one solar mass star. Let me speed up the simulation. Zoom in. It's going to completely destabilize all the orbits. It's going to destabilize any kind of planet. If Sirius had a planetary system before its encounter with its companion, the planetary orbits would be completely disrupted, and perhaps all the planets would be ejected from the system. Look what it's doing here. Let's speed it up a little more. Mars is way out here. Okay, Venus is going way off here. Okay, so the presence of it was bad enough when we had the two solar mass object here at Sirius, but now we introduce Sirius B. It's another one solar mass out at the orbit of Uranus. The planet Uranus orbits the sun at 20 astronomical units. It's at that distance. So the presence of a one solar mass object at that distance is going to completely disrupt any kind of planetary system that was present here. Had Sirius A and Sirius B come together through a mutual gravitational attraction. And Sirius B adopted the orbit it has now through such an encounter, any planetary system that was there would be completely disrupted. All right, today's the 12th. Over here we see, this is at 6 p.m. We see Jupiter and Saturn here. The sun is already set about an hour and a half earlier. And Jupiter and Saturn are way down here, low in the southwest. Okay, Sirius hasn't risen yet. Here's Fomalhaut. Okay, Aldebaran is just coming above, just above the eastern, rising in the east. And Orion here. Here's Bellatrix and Betelgeuse right here. Here's Betelgeuse and Bellatrix right here. These are the shoulders of the Great Hunter, and his club and shield are right here. I beg your pardon, this is shield. Okay, here, the Pleiades. We're going to talk about the Pleiades and other beautiful aspects of the winter sky in a later video. Okay, so let's advance the time a little bit. Okay. So right now it's coming up on 7 p.m. 7 p.m. Eastern Standard Time. Sirius doesn't come up until Sirius and Canis. Sirius will be the first to rise. There's Procyon right there. Sirius is coming up now. Okay. And Sirius and these constellations will be with us well through March, almost into April, well into the early spring. Okay. And so this is basically 10 p.m. at night. Okay, tonight, December 12th, this is what our sky will look like, looking south-southeast, or southeast rather. Let's remove the Milky Way, we're going to remove the atmosphere, and we'll see the subtle winter Milky Way. So if you have an opportunity, perhaps over the holidays, to travel, try to take a look, if you're away from the city lights. Go out, look southeast at around 10 p.m. at night. And if you have a clear, dark sky and a dark south, you'll see pretty much what's here, what we see here. The subtle winter Milky Way is beautiful. When we take a look high overhead, you'll see all the jewels of the winter sky, which we'll get to in a later video. All right, folks, I hope this video was educational, that you enjoyed it and learned something about astronomy and science. And please look forward to our next video. And please invite others to join and take a look as well and share. The great philosopher Plato famously said, "Astronomy compels the soul to look upward and leads us from this world to another." Astronomy for Change is a nonprofit organization whose mission is to effect positive change through astronomy and science education. It is our belief that by inspiring and empowering current and future generations to become interested and engaged in astronomy and science, this positive change will be realized. If you found this video helpful and educational, please like, subscribe, and share. Also, why not consider supporting us on Patreon? Head over to our homepage, astronomyforchange.org, click Support Us via PayPal or Patreon, and choose a membership level suitable for you. Every little bit helps us produce the great content and further our mission. Also, why not consider becoming a member? Membership is free at Astronomy for Change. Head on over to our homepage, choose the membership link here, click it, put your name and your first name and your email, and you'll be added to our list. You'll receive a comprehensive digest of all our videos and articles and all our great content. Joining and becoming a patron, helps us grow and more fully realize our mission. Thank you. This is Dr. Jim Daly for Astronomy for Change. Until the next video, please stay well and keep looking up.